Right, thanks for coming. My name's Don. I'm the designer of the F# programming language. I work at Microsoft Research, but right now I'm very, very happy doing a 2-year gig with the Xamarin team, the Microsoft Mobile Tools team, working with Miguel de Casa and the whole gang who make the Xamarin tools for the Android and iOS platforms, which are fantastic tools for doing .NET programming, targeting Android and iOS, and also covering a range of other device kind of oriented work for .NET programmers. And so today I'm working on this kind of new talk. I discovered this was a talk I initially gave at F# Exchange, and I discovered that people actually really like it when the language designer talks about code they like and code that they don't like in the language. Okay, that's we can all talk about the features in a programming language and maybe the history of it and the background of it. I'll kind of cover some of that, but we also want to know how to use the features well. And just because I've got an opinion on that doesn't mean I'm right about that, but I guess people like to at least hear my opinion, and then they tell me their opinions back pretty strongly about the right way to use F# or the wrong way to use it. So one way of approaching that, instead of just saying, hey, let's have an argument about coding styles or something, is just say, look, I look at this code and I really love it. This is what forms part of the reason about why F# exists, is to support some of the different kinds of coding that I'll be talking about. I will be talking about object-oriented programming a little bit and how object programming kind of plays out in F# and where we kind of find a place to stop on the slippery slope of object-oriented programming. There are places you can stop on the way down without going all the way down. Right. So let's begin. As I said, it's opinion. I've covered some of this. Now, some of you might not know much about F#. I understand that. The last time I gave this talk was to an F# oriented audience, and I've tried to rejig it a little bit. Probably haven't done that completely. So if you have some familiarity with F#, if you have some familiarity with a language like Elm, or with maybe you've done some functional programming somewhere in your background, then that will help a little bit. But it's a pretty lightweight talk, so you should be able to follow along. So what did Microsoft say F# is? F# is partly sponsored by Microsoft, but this is what is on the Microsoft.com net site for .NET programming. F# is the open source cross-platform functional language for .NET, and that's why it's there to fill that niche in the .NET platform to support functional programming extremely well in the context of .NET. And that's why we started F#, and why it exists today is because that's an important, economically, commercially, technically valuable thing to be providing in the context of the .NET ecosystem. And it's valuable because it's a super productive and super accurate way of programming, and that can be used for all sorts of different things, but it's because we want to bring functional programming to .NET and to bring .NET to functional programming. I probably said that in like 2005, 2006, when we started F#, those are probably the exact words I used, and that's still why F# exists today, and it's a mission it needs to serve. That said, F# is actually more than .NET these days. I'll be covering that. F# has a fantastic JavaScript compiler. Has actually two great JavaScript compilers. The one I'll be mentioning today is called Fable, and it's particularly good because it really brings F# into the JavaScript ecosystem. It's packaged as a Node npm package. And so if you're in the JavaScript ecosystem, you'll find it very natural to use F# as the way to author JavaScript code in a similar way to how TypeScript is done as well. Okay, so this is a little bit about where F# is today. As I said, F# is open source, it's cross-platform. There's a certain sense in which it's, as a language and as a community, it positions itself to be neutral. The word neutral can mean many different things. You have many different contributors to a language. There's sort of a demilitarized zone. There's a group called the F# Software Foundation, which is a non-profit organization in the United States. It kind of is a similar thing to the Python Software Foundation. It's set up particularly for sort of community and educational purposes, and it allows all the different people who contribute to F#. Microsoft is one major contributor. They sponsor my time, and they sponsor several other people to work on it, but we have contributors from JetBrains, we have contributors from companies who use F#. Relatively speaking, F# is a relatively sort of contributing community. There are lots of the companies using it also contribute to the actual tooling and the whole stack, from language design all the way through to tooling and libraries. And it's we think of it as independent in that kind of neutral sense. There are contributors, but there's an independent zone where everyone comes together, and that's primarily through the F# Software Foundation and their activities. So right across the stack we accept contributions, right through all the tooling. That includes the visual F# tools. For Visual Studio, it includes Visual Studio Code plugins for F#. It includes the JetBrains Rider tooling for F#. Right across the stack. It's a very self-empowered community. There's the F# community through the F# Software Foundation very much own the message about F#, about what it. We wouldn't, if you go to look for testimonials about F#, you wouldn't go and look for Microsoft case studies or something like that. You go to the F# Software Foundation, they own the story, and they're very good at telling that story in a powerful way. So fsharp.org is the place there. On the professional tooling side, the Xamarin, the group I work with, now Microsoft Mobile Tools, provide F# tools for Android and iOS, and I use those every day, and they're great and getting even better. The visual F# tools are Microsoft's sort of professional tools. They are part of Visual Studio, all the different profiles of Visual Studio. And for the cross-platform story through to Linux and OS X, we of course have Mono, but we have the Debian and RPM packages, and it's incredibly good cross-platform story through .NET Core. Underneath this tooling, there's a single component called the F# compiler service, which is really the implementation of F# available as a library. It's got its type checker, it's got its parser, it's got its lexer, it's got the colorizer, it's got all the different pieces that you need to analyze F# code. It's got the dynamic execution engine. It's got the code gen engine. This actually cross compiles to JavaScript, so it has a version of the F# compiler service component which is entirely JavaScript used to generate JavaScript in the browser, so F# compiling itself in the browser, and so that's a component that underlies everything. I said there's Fable for F# to JavaScript, and something I won't be talking about today, but it's an incredibly exciting development for F# is this kind of opinionated full stack, putting some of these pieces together, a thing called Safe. If you could just Google for that. And that basically takes a web story, which is called Suave or Saturn, built on ASP.NET Core, takes Azure, takes Fable for F# to JavaScript, and what's the E for? I forgot what the E is for. Fable, and Elmish is the way of, I will be talking about that, the way of programming the dynamic web view using an Elm-like programming model. It's a really great stack for end-to-end programming with F# from client right through to server. And on the language design side, we've just finished up on F# 4.1. I'm beginning to put together what's in F#. We'll probably, for various technical reasons, jump straight to F# 4.5 because we used up some version numbers in between in some silly releases of various components, so we got to align everything and just go straight to F# 4.5. We have a language design process you can get involved in. You can look here under the F# Software Foundation's GitHub organization of the design. Usually start with suggestions. You can vote on them, comment on them, put whatever you like there. The design is where the RFCs go, and then they get translated into pull requests to the actual implementation. That's what we did in F# 4.0. I won't go through that. Just the usual sort of list of things we did. F# 4.1, we did these. We focused a lot on allowing people to use these unboxed struct representations of a range of different data types in a very sort of simple way, just by adding an attribute to things. Right. Okay. So that's the VS Code plugin. Very community-driven. Great bit of tooling for F#. Get Visual Studio Code, open an F# file. It'll prompt you to install these tools called Ionide, and give you your editing, whether you're on Linux or Mac or Windows or whatever. This is the .NET Core story. F# is in the .NET SDK, which is the SDK for .NET Core programming. It's a default part of that SDK. It's wherever you see F#, wherever you see .NET Core, C# and .NET Core being supported, F# is also going to be supported there. For example, you can do .NET Core programming to do AWS Lambda functions, and they of course did the C# samples first. Just yesterday, because they're running those with .NET Core, just yesterday they put out the AWS Amazon put out the templates for doing F# AWS Lambda functions. Right, this is how you get started. .NET New --lang F#, .NET Build, etc. Just the usual thing with .NET Core, and you can find out more here. Right, and that's the Fable JavaScript compiler I mentioned. It uses Babel underneath, produces good JavaScript code, and has, I've just looked that up and follow through if you're into the front end programming. And just to say, just on the summary about F#, the methodologically it feels very different to C#. Okay, it's like, and the way we capture that in a pair of words is to say that F# people adopt functional first programming. And that will play out what that means in some examples, but it does feel different, and I'd encourage you to get into the mode of what it means to be an F# programmer. Don't just approach it as like, oh, another syntax for C# or something. It's not like that. Methodologically, it feels and is different to C# programming. So some affinities, as of course, there's lots of relationship, but the functional first approach is a great one. This was one analysis done for basically the same project. It was application to evaluate the revenue due from balancing service contracts in the UK energy industry. An analysis done by Syme and Cousins. That was, there were differences here beyond the language. This was an offshore team. This was a tight team of 2 or 3 F# programmers working in the UK. But you can see there's scales of difference here. And the C# project took about 5 years, had about 8 developers, and didn't implement all the contracts. The F# project took less than 1 year, peaked at 3 devs. Only 1 had prior experience with F#, and all the contracts were fully implemented. What were those lines of code? You can see here we had 56,000 lines of braces in the C# code. We had lots of blank lines. We had 3,000 null checks. We had lots of comments, but maybe I don't. Anyway, okay. Yeah, maybe this could have been a bit higher. I like comments. Comments are great. Right. Then you can see the test codes. There are plenty of tests in the F# code out of the total. Here, 1/3 of it was tests. Actually, so a higher proportion of tests in the F# code than in the C# code here. Just to say, one particularly telling statistics is this one. This is 2,000 try-catch statements in the C# code. So that clearly exceptions had got completely out of hand in this. It was an asynchronous application. I don't think they were using the async features of C# properly, and they're probably just wrapping try-catch handlers around every single callback and then not having anywhere to send the exception when they caught it, and just kind of logging it or something like that. And there's like 9 in the F# code. And that doesn't surprise me too much. They clearly had things under control in the F# code, and that things were out of control in that C# code. And Simon has a It is by no means true for every F# project. This is absolutely not true as a universal rule. But Simon likes to tweet on Friday afternoon, I just deployed to production, I'm off to the pub. Things like that. So whether he's managed to maintain this record of saying 0 bugs in deployed systems, he did say to me that they had to call up the balancing services and whoever, revenue department or whatever, to check that the system was being used because they were getting no bug reports back. But he's adamant that F# is a safe choice in this particular energy sector industry. Right, okay. And finally, this translates through to big business results. This is the first ever unicorn on the Azure built using Azure. First company valued at over $1 billion. They are nearly an all F# shop, Jet.com. Great stories behind the history of Jet.com and what the guy who did Jet.com did before he did Jet.com. He took on Amazon again. This is really taking on Amazon in the United States, and that's why Walmart have acquired them. Before this, he did diapers.com, which was taking on Amazon in the parenting market. Because if you get people buying diapers, then you can get them buying a whole range of parenting goods. And then Amazon eventually bought out diapers.com because they were a big enough threat to their market, to that part of the market. And then he came back again and he took them on again in Jet. And now that's acquired by Walmart. And the valuation at the time of the acquisition was over $3 billion. Right. So of course Microsoft is super happy about that as well from a business point of view. They see high value things being produced with F#. Of course there are lots of high value things being produced with C# as well, there's no doubt about that. But we invest in .NET partly because it brings revenue to and brings success for our platforms like Azure for F# and C# and .NET. Okay. So let's talk about code I love. So I mentioned this, I'm the language designer. I could tell you about the features of the language. I've got talks about that. But people have been asking me, no, we want to hear tell us about F# coding. What is it that you like and what is it that you don't like? So as I said, I could say what I think, and I will do that. But there's a fantastic resource called the F# Advent Calendar. It started by F# users in Japan, I think way back in 2010, and they've done it all the way through 2017 as well. I can't read those because they're in Japanese. I guess I could Google translate them, but more recently we've been doing it in English as well, and we get anywhere from 20 to 50 different people, 2 or 3 per day in the December season leading up to Christmas, putting out blog posts on, what they love about in F# coding, putting out, it's a very focused time where you get to summarize what you've been doing with F# during the year and what are those particular moments that you really love about F# code. And so there's lots and lots of good resources in that setting. There's some from the F# Japan calendar, for example. Okay, right. So when we go back in time to when we started F# back in the mid-2000s, here's one of these, man, isn't that great? That's like, look at how round those buttons are back in 2007. It's like really going back in time for me when I could use this as a modern slide. Not anymore, it looks ancient and awful. But anyway, this is how we described F#. It said it's the combination of these things that we're trying to get. We want to bring the world of static typing, and you can actually take any 2 of these, and there's a lot of technical tension between these things. If you take Java, they get static typing, they don't get succinctness. I just heard in the last talk, wow, Java's got var. Yay, you go for that succinctness. They're working it out now. We provoked C# to get var, and C# provoked Java to get var. The best way to do technology transfer in this is technology transfer by envy. Okay, this is the way you influence the world: is you do something and you make everyone else envious, and gradually things go through the system. Okay, of course we got these constructs that combine this from OCaml. The history of F# started with trying to bring the core of the OCaml programming model into .NET, and this problem had been solved quite a long time ago, and so good. We want that combination, but we don't just want that. We want the code to scale, and that does mean embracing object-oriented programming or object programming to some point. We want to have the access to the full libraries of .NET. We want exploration and interactive programming in F#, scripting and dynamic evaluation modes of using F#. We want to make sure this language is highly interoperable. This was historically a major problem for functional languages, that they could, you could get some of these things, but you wouldn't get the interoperability. You look at a language like Haskell, it struggles with interoperability in many ways. It uses a different VM, it doesn't get the library base, its data types aren't immediately interchangeable, and so on. So we wanted that to be solved in the context of F#, and of course Scala took a similar approach in the context of the JVM, and we wanted to make sure things were running efficiently as well. Okay, so given that, that was the starting point. You can assume, it's fair to say that I love code that is succinct. I love code that is expressive in that functional programming way. I love code that interoperates, performant, accurate, and is well-tooled, because that was always what the combination we've been trying to achieve. Okay, so let's start with an example. So there's an example. I love that code. Yep, this is a valid F# program. Okay, this is, you don't need anything else, no ceremonies, succinctness. To start with, here's an expression, printf with a new line, hello world. That's an F#. That's an F# program. And that's got the attributes down here. It's succinct, it's expressive, could be much more expressive. It interoperates well enough, uses the .NET libraries underneath to do the I/O. It's performant, has a low bug rate, and as well tooled. You hover over printfn and you've got the documentation for it, and that's nice and good. Okay, that's a good start. Okay, so I'm going to run you through some things that are very normal in F# code. I'm not going to labor them too much, but just tell you things you'll see all the time in F# blogs and F# coding samples. So if you take pipelines, you'll see this, take x, some value x, and pipe it through some function. It's the same thing as taking the function, call it F1 here, and applying it to X. Okay, so you'll see this all the way through F# code. People love it. People go and suggest that it should be added to other programming languages. There's proposals to add this to JavaScript or whatever else. People seem to love it. And you can chain these things together to get a kind of one way of composing functions. You can pipe it through F1, F2, F3, and so on. Okay, here's a typical example. Just took a random bit of F# code, but this occurs all the way through every F# program. You take some symbol uses and you filter it through some function, and then you do a parallel map to use the multi-core capabilities to transform that, to partition it and transform each partition in a multi-core way. Then you collect up the results and you do a filter, then you do a grouping, and then you do a map over all the different groups, and bang, 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 so on as you go down. Okay. So I won't labor that anymore, just to say I love that code. I love the simplicity, the compositionality of it, it's only when I have to drop out of a language that supports this way of working that I realize, man, I really want to be able to write this code. I really like being able to write it. Okay, you will see this consistent thing throughout F# blogs and samples, that people love using F# for domain modeling. Domain modeling, both the types in the domain and the semantics of the domain. And there are many different examples I could choose. I'm choosing one initially because I came from research. This is the sort of stuff that researchers love to play around with, right? Where it's sort of representing the parse expression for a Boolean logic kind of domain. Maybe you're dealing with hardware. In fact, my job before I worked at Microsoft was with Intel. Where we use these kind of modeling languages to model combinational logic or register logic, to model what the floating point circuits on a Pentium chip should do, and then we build these really succinct clear descriptions of what things should do, and then we compare them to the actual reality of what the chips do and try and find bugs in the implementation. So, so this might represent the logic of the combinatorial logic on a chip. And so that's fine. We have and, or, and so on. And then you just go ahead and you start writing recursive functions that do evaluation, that do normalization, that compare to a net list on an actual chip using analysis techniques, or you visualize these kind of things. Okay, here's a more domain that I work in every day. This represents the optimization information known to the F# compiler. So when F# is compiling your code, I can actually just read this off to work out what does the F# compiler know about your code. Well, it might know nothing about some expression, or it might know that some expression is the same as some other value, that whatever this value is, it's the same as that x over there, this valref. And we know some more things about it. We have the valref, what it's equal to, and we know some more things. We might know that your expression was a tuple, and we might know some element about each of the things in that tuple. We might know it was a record of a particular type, and we know some more things about each field. We might know it's a union case, which case it is, and what we know about the data it's carrying. We might know it's a constant, like your code 3 + 2, that evaluates to 5. So this will be filled in with 5, and we carry around the type of the information there. And we might know, your thing is actually a function value, because we might want to inline it. Okay, that's for inlining the code. So, and that's all that the F# compiler knows about your code in the optimization phase. That's our model. That's the domain, and you read the rest of optimizer.fs in the F# compiler, and it's all about this. It's about producing these values and consuming those values in sensible ways, in accurate ways to optimize your code. So for me, as a compiler writer, that's my domain, that's the model of the domain, and it's as clear as crystal what we do and don't know, and that's what people love. Now, people use this domain modeling thing in many other approaches. I'm not an expert on domain on all the applications of domain modeling, but this guy is called Scott Wolashin, some of you might know, does the site F# for Fun and Profit, is an expert, and he's a really good teacher on domain modeling. I'll talk about his book in a moment. This is the domain model for error results coming from coming from some service we're interacting with. Here is a domain model of some XML, I think some XML data that's coming back. This is done by a guy in Nigeria called Odi, a wonderful communicator about F#. And some of these quotes are worth reading too. The choice of data structures or how you design your domain is crucial when writing a code in F# or any language. Screw it up and you'll be walking around in circles. Nail it and your implementation will be concise, straightforward, and perhaps even trivial. And this, if you want to know more about domain modeling in F#, it's really at the core, for some people, it's at the core of the value proposition for F#. There's this slightly out of focus, Domain Modeling Made Functional. That's a book by Scott Wolashin. I strongly recommend to people. And also this book, Get Programming with F#, is also a great resource. That's fresh out in the last few months and also highly recommended. Okay, so that's what else. So when you look through those Advent calendar blog posts, about half of them are to do with domain modeling and its clarity in F# and the clarity of both the types and the semantics that go along with the types. So this is the place to begin, in a sense, to understand why do people love F#, what's the value proposition, what's the code that they love. Okay, I want to move on to a different area, which is something I'm working on at the moment, which is in this using functional programming and lots of immutable data structures to do reactive functional user interfaces. And so this is using this view model update architecture for front-end programming. And in this architecture, the view function effectively gets called on every single update to the model. So the model here is immutable data, and that's a really nice characteristic to have, because it means you can, at any point in your code, you can dump out your model, you can you can play back in time through a history of models. Okay, you can unit test. If you've got functions that take immutable data, then you can unit test these things really nicely. You can say, okay, given this particular model representing the underlying knowledge of the UI, and we make a view of it, then we should get certain things appearing on the screen, for example. Or we could there's a corresponding update function that takes messages and processes them through the model and gives you new models. And again, really easy to unit test. And there's this business that there's no mutable state in the coding of the system. It's a really lovely way to program functional reactive UIs. So it's based on the Elm architecture. This is called the Elmish model for F#. It's supported by Fable. This all becomes JavaScript code. You can see here that these things are great for dynamically adjusting UIs. That if we have some text in the model, or we've got no text in the model, that's an empty array, then we say loading, a div called loading here. And if otherwise we have a button here that says go faster, put the text here, and then we say have a button saying slower, and then we have something reporting the performance of the system. Okay, so these view functions are something I'm really falling in love with as a way of coding UIs. It's functional reactive dynamic web view. There are various tricks you need to play to make this stuff efficient, because this view function gets called on every single update to the model, and there's various ways that are documented in Fable and other such systems about how to make sure you pay per update. You don't you pay the performance ends up reasonable. This is the same thing applied to Xamarin programming, which is what I'm working at the moment. I'm loving this view model update architecture so much that I'm going to apply it to Android and iOS app programming. So here we have a view function. We're taking again a model. It's a dynamic view function. If the pressed is true in this immutable model, then we show a label. Otherwise, we show a button. So people familiar with XAML will see that we're doing the XAML completely in code. We're not going to write any XAML files. And this means a whole lot of state disappears from your system in a really nice way, and you can just focus on code rather than this big mess of files in a XAML-oriented system. This is using the Xamarin-oriented version of XAML. Okay, so it's a functional reactive mobile app view in that case. And just to say, an entire app, this is an entire Android app, or iOS. You can run the same thing on iOS using Xamarin. This is the full application, okay, rather than having tens of files in your system. So let's run through this. We have the messages that can be sent from the user interface, from the view. We have the model, is the thing pressed or not? We have the initial model, it's false. We have the update function here, how we process messages, how we process the pressed message and the new model that we get from that. And then we have this dynamic view function, which is the one we just saw. If the model was pressed, we said this. And otherwise, we have a button. And then we have some stuff to put it together at the end. Okay, and nice and succinct. And I showed this to a program manager at Microsoft the other day, and he said, that is F something clean. That is like as clean as you can get for how you're going to write a mobile app. Competing with an 8-year-old and competing with the sunshine. Tricky time to give a talk. Yeah, I don't. Right, I'm going to skip this one here and check how we're doing on time. Yeah, okay. So this one was just about scripting and writing tests with scripts. I love that in my day-to-day work in F# code. And this is about composition, one sent in by the community. This is the compile function for a full compiler, and you just see the phases here going lex, parse, bind, optimize, codegen, and just the fact that the language encourages you to work towards a compositional approach to your programming. Okay, F# has a feature called type providers that is just full of magic moments where you take data sources such as CSV or other data sources and bring them into the language. I'm not going to talk about that in more detail, but I encourage you to take a look at those. Okay, now I'm going to talk about some code that I don't love. Okay, And that is, there's some functional programming code I don't like, okay? I'm not going to say that all functional code is good code. And I want to talk a little bit about that. I'm going to give some examples. Here are two functions you'll sometimes see used in some functional programming things. A curry function and an uncurry function. This takes, I don't really care what they do because I don't like them, right? Okay, I don't like it when people write this kind of nonsense where you say, actually, this is the right way to do this. You just take string.compare and give it to two arguments. You don't do any weird nonsense to try and do this. It's just wrong, all right? So don't do it. Okay, so I don't like this. You just write this stuff. It's indecipherable. I just prefer, quite often, just write the damn thing out. Okay, if this thing took two arguments in sequence like this, then just write it out explicitly. Okay, so there are places. So it's hard to catalog all the ways people can write indecipherable F# code, and you just don't do it. You just look at your code and analyze it for readability and traceability, and you don't go around just sort of doing things because they're cute. And so these things are not in the F# standard library because I think they lead to bad and indecipherable code. Okay. This one is in the F# library. This is the back pipe operator. I talked about the forward pipe operator, which I really, really like. So we put in this back pipe operator as well. And it's really, there are some uses of this where you can eliminate some parentheses by doing this, but I just really dislike this code. Whoever wrote this, I just don't want to ever see that kind of F# code. I do want to see much more sort of sensible kind of piping operator, forward piping operator code like this. So I don't want F# people to use the backpipe operator, certainly not in beginner code, and use it a lot less than we do. Okay, these are even worse, and they should never have been in the F# core library. We should just never have put these in, and we shall kind of get rid of those one way or the other. We'll start deprecating those or warning those or something. We'll eventually flush them out of the system. Okay, so now there's this style of doing functional programming where you're basically trying to get rid of any explicit variables, and they call this point-free code, okay? With no explicit lambdas and no variables at all, but just using lots and lots of composition. This double operator here, blah, there. That's not the aim of, first-class functions are a good thing, but point-free is not valuable in itself. Here's some examples of what people do. They take list.map and take the plus function and saying attend. So they say, oh, isn't this cute? We're going to add, but they haven't even put the argument in here. What list are we? Just put the argument in, okay? Just say, well, we've got some arguments here, and we've got to put the argument at the end here, and same with this. I don't like this code at all. So point-free is not is not a virtue in itself. So just do the obvious thing and say, if you want to add 10 to something, then write add 10 to x is x plus 10. And if you want to double and increment something, then you do that with a nice name here. F# likes nice names in its code, or at least I like it. There's some good guidance on this by a guy in the F# community called Eric Tsapalis. He works for Gedcom in their coding standards team about, excuse me. There are some times you want to head more point-free, but on the whole, it carries a big burden of proof before doing this kind of thing. Okay, so please give explicit arguments to functions. Okay, you'll see a lot of fold in functional programming, but fold is an interesting thing. That's where you take all the elements right across a data structure, if it's a tree or whatever it is, and you kind of iterate them all and collecting up some kind of state along the way, and then you get to the end and produce a result. It's an important thing to know about, but it's kind of like a blunt instrument. It's kind of like a go-to. It's not using the structure of your data. There's a great paper by Guy Steele about sort of fold considered harmful because you can't parallelize it. It's not using the structure and knowledge of the data that you're working with. So it's nearly always better. If you want to add something up, well, do it using these kind of operators: sum by, max by, choose an operator, try and pick one of the elements, or doing a map and a fold if you're really going to do a fold, or do a reduce. You're usually doing something which carries some kind of relationship to the data you're working with and the kind of operation. And it's probably already defined in the F# standard library, and you should go and use one of those. So I'll skip that. But sometimes fold here is as hard to understand as a while loop. Folds can be very hard to understand, and beware that they carry a burden of proof. You shouldn't necessarily be using them. Use something better. Okay, F# has this record type feature, which gets used hugely in those immutable models. And it's a really lovely feature because it's so easy to define. Here's the initial state of a program. Here's some maps or so on. Okay, so people love record types, but these things can be misused, okay? So record types are good when the internal view of a type is the same as the external view of a type. When these things add up, they're the same thing, okay? But when they're not, when there's some need to encapsulate these things, or you're adding more to the interface, then maybe records are not what you should be using. And so here's an example where actually it's bad because these refs actually represent an old-fashioned way of doing mutable state in F#. And so you actually really want to encapsulate this mutable state. You don't want to leak it out right across your code. So I have seen some F# code. It was based on OCaml code originally, that lets this stuff leak out everywhere. The problem with records is this stuff begins to leak out. Okay, so beware record types when you need to encapsulate these things. So in this case, you would use an object type. You actually want a mutable program type here, so you'd make the things explicitly mutable where necessary, and you would encapsulate them. Okay, and I'm going to talk about object-oriented programming now. Okay, so use record types if things aren't symmetric. Okay, right, so in the last 10 minutes, I'm going to tell you about some opinions on object programming, both good and bad. Okay, so here's what object programming looks like in F#. Okay, we're defining a class called vector2d, nice and succinct, nice and functional. Takes two inputs in its constructor. It's what we call an implicit constructor at the top here. These things become fields in the type. We don't make a field if they're only used in the construction process. This is the construction process here. So but these ones are actually captured in the properties here. So that becomes another field here. And we have some published properties here, dx and dy. They're just properties in the .NET sense of properties. We have another property here. We have a method down here which produces a new vector with things scaled. Nice functional object type, showing that functional and object-oriented programming can work perfectly well together. So that's good, and that's just running through what I just said. So these are the constructs in the language. We have these constructed class types, all very nice. We have these interface types, standard .NET interface types, and we have expressions here. So you can actually have these expression forms where you create objects, or you create objects that support some interface. And they sort of nice object expressions. Good, so that's nice and simple. Okay, so here's an example of some early F# code that made me realize F# was heading in the right direction. We have a nice class type, and we take in some kernels, and we do various functional things to create an augmented view of this kernel's data, and then we publish those as indexes, methods to access that data structure. So that's good, a functional computation of encapsulated tables and their summaries. Nice and very common coding pattern in F#. Okay, but so we're going to support object-oriented programming in some way, then, well, as I said, there's a slippery slope. And so something I did during the early F# design process, and I eventually wrote it up, was to actually deconstruct object-oriented programming into these lots and lots of individual features. And people have been encouraging me to do the same with functional programming as well. And I just want to, so what I've done here is basically order them from things I like to things I don't like so much, okay? And sure enough, as you go down, there's a cutoff point around about here where things aren't supported in F#, okay? So let's just group these together, okay? What do we do with all of these, okay? Some of these are there, some of them make F# a genuinely better language, okay? F# is a better language because it supports object programming. Okay? Some of them are needed because it's a .NET language, and some of them just aren't really needed at all. So let's go through these. So these are the things that I absolutely love and embrace as part of F# programming. Dot notation, great. Instance members, implicit constructors, we've seen that. We can have static members, you can have indexer notation, named arguments, optional arguments, interface types, and their implementation. So this is all great. Okay, so we embrace those. When we look at these ones, okay, we have some mutable data, it's optional in F#. We have this IDispose, IEnumerable, extensions, structs, delegates, and so on. A lot of these are .NET things, okay? So these are things which we use where necessary, but we ask you to kind of use them tastefully, use them respectfully, use them sparingly, be sensible about their use. Okay, these are things which are getting, more in the don't like category. Okay? Pervasive nulls, we really don't like those in F#. Implementation inheritance is really strongly de-emphasized. This large type hierarchy, if there's one thing that F# doesn't embrace, it's this hierarchy-oriented thinking that sort of comes from Java and the early object-oriented days. Cat, person, dog kind of thinking. Cat, animal, dog. Okay, so these are going down the rabbit hole of object-oriented programming. If you find yourself doing these in F#, you probably want to step back and rethink how you're doing these things. And then there's some things down here which aren't supported at all in F#. We don't do supported protected members because it's so strongly associated with implementation inheritance. And there's some things we can't do because of .NET. And probably self-types is something we would do if we could. So basically we love these, we tolerate these, we mostly avoid these. There's nothing technically stopping you doing some of these things, and just forget about these ones here. Okay, so the way we characterize that in F# is to make a distinction between object programming and object-oriented programming. Okay? So in F#, when you're doing object programming and you're doing it well, then you're focusing on notational convenience. You're focusing on making great APIs, and this is something that C# does so well. It's like, its object-oriented programming is really focused on this API ergonomics. That's good. We want that kind of thinking in F#. We want good naming, good encapsulation, composable abstractions. And we want this thing at the bottom, we want you to be making simple things out of encapsulated complex foundations. Okay? If we compare that with object-oriented programming, okay, too often it means these things. Objects is the dominant only way of thinking about things. It's everything is an object, everything's in the hierarchy, you must think about the hierarchy the whole time. So there's overuse of hierarchical classification, animal, cat, dog, whatever. Okay? Object-oriented programming leads you to these large abstractions with lots and lots of holes and lots of failure points. It focuses on declarations rather than using expressions and closure. And there's this thing that implementation inheritance does, which leads you to make complex things from other complex things by inheriting complex things. And you only can make things more complex by implementation inheritance. You can't make things simpler. Okay, and your aim should be to make something simple out of correct components. Okay, so the F# approach is to embrace object-oriented programming, make it fit, but don't embrace full object orientation unless maybe you happen to be already in a code base where you have to use that technique. Okay, so we find a place to stop down the rabbit hole. Okay, I'm going to skip a couple of sections here. I'll just run through these, just mutation, I'll skip those. F# has this wonderful construct called sequence expressions for creating sequences of data. You can use with lists or arrays as well. And there's some beautiful examples of this kind of thing. Really capture the complexity here. So we're creating a list of things and we yield. If this is true, then yield, 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 all the way down. Then we recursively yield at the bottom. And this is a beautiful way of writing these kind of lists and logic, which otherwise you really need a good notation for writing this kind of thing. It's built on the same machinery we used to write async code, which was pioneered in F# back in 2006 and then became part of C# and so on. Here's one example I particularly like. We take some server, client, and browser. We put them all in parallel and run them all. That's from, I don't know, I did something about that. I thought, yeah, okay, I really know what that's doing. I can see what it's nice and declarative, yeah. And that's the slightly larger version of that, the definition of the server here, definition of the client, definition of the browser, put them together, run them in parallel, and wait for the result. We can do that with sequences. Async seek here is a similar kind of use of this general machinery in F# for defining these little languages, these compositional languages. There's async maybe, and we're starting to see people doing really interesting things with web programming here. This is defining the logic of a web API in this scope here, where you're defining the forwarding here, and so on through the API. Very nice. Okay, to add a few general comments, I love all the software engineering side of things, debugging, commenting, testing, performance, putting things under CI, making sure the code is readable. Nothing's meant to, those are foundations in any language and applied to F# just as much. So please do all the sensible things you should do in any programming language. Good names, good stack traces, good debugging aids, and good comments. So I've tried to encourage you to see that F# is full of these delightful moments where people really love the code they get at the end of the day. The features can be used well, they can be used badly. So if you're an F# programmer, please share your experiences and help to improve the coding standards, and make sure we delight even more programmers with this language. Okay, and that's it. Thanks very much. Are we taking questions in talks, or are we just doing general discussion outside? I don't know. Any questions? Yeah. Oh, yeah, go on. From an F# point of view, well, it's not something you'd bake into the programming language. I think I just prefer those, what the kind of transformations that they're trying to do in aspect-oriented programming, I prefer those to be explicit and under the control of the type system in the language. And yeah, I think people always just say logging or something like that as being the classic example of that kind of thing. And I just don't see enough compelling examples of its value to really centralize it as part of programming methodology. Yeah. Let's do the rest of the questions outside. Thanks.